Welcome. This is SO 305, Lecture 7. Measures of central tendency, mean. Introduction. When a series of observations has been tabulated, that is, put in the form of a frequency distribution, the next step is the calculation of certain values, which may be used as descriptive of the characteristics of that distribution. These values will enable comparison to be made between one series of observations and another. The two most important types of numerical summarizers are 1. Those that locate the center of a distribution of data, called measure of central tendency, and 2. Those that describe the speed of data values about the center location, called measures of dispersion or variability. In this lecture, the first measure of central tendency will be considered. This is the mean. Objectives. At the end of this lecture, you should be able to calculate the mean for grouped and ungrouped data and calculate the mean via assumed mean coding method. Pre-test. What do you understand by arithmetic mean? What are the properties of the mean? Content. The mean. This is the most commonly used. However, there are situations where the mean does not provide a good measure of central tendency, or where it is impossible to compute a mean. These are: A. When a sample contains a few extreme scores, unusually high or unusually low values, the mean tends to be distorted by the extreme values so that it is not a good central representative value. B. When sample data consist of measurements from a nominal scale and are not numerical values, for example, gender, occupation, eye color, and so on, because no numerical values are involved, it is impossible to compute a mean value for such data. The mean is computed by summing scores and dividing the scores by the number of individuals. The mean for a population is represented by U, the Greek letter MU, while sample population is represented by X bar. The mean has various types. In this lecture, we shall discuss only the arithmetic mean. Properties of the mean. The mean has many important properties, namely: 1. The mean is sensitive to the extract value of all the scores in the distribution. Any change in any of the scores to be calculated will cause a change in the mean, because you have to add all the scores to obtain the calculated mean. This is not true of the median or the mode. 2. The sum of the deviations about the mean equals 0. That is, E bracket xi minus x bar bracket equals 0. 3. The mean is very sensitive to extreme scores. The mean will have to shift a considerable distance to re-establish balance when extreme values are involved. 4. The sum of the squares deviations of all the scores about their mean is a minimum. That is, E bracket xi minus x bar close bracket square is a minimum. 5. Under most circumstances of the measure used for central tendency, the mean is least subject to sampling variations. Arithmetic mean. This is the total of the values of a variance divided by the number of values. 1. For ungrouped data without frequency, the mean represented by x bar, read x dash bar, is written as x bar is equal to x1 plus x2 plus xn divided by n is equal to n exi is equal to 1 divided by n, where E is equal to sigma addition of all variables, x equals to observed variable individually, n number of values of the variables, I take value from 1 up to n. Example, a variable has the following values: 2, 4, 6, 8, and 10. Calculate the mean. Table 9, solution. 2 plus 4 plus 6 plus 8 plus 10 divided by 5 is equal to 30 divided by 5 equals 6. 2. For ungrouped data with frequency, the mean is calculated using x bar is equal to EFX over EF, where x bar is equal to mean, Fx equals total product of value of x and corresponding frequency. EF equals total of all frequency. For example, find the mean for the score in statistics test in table 2. 3. To calculate the mean from data with frequency and class interval, since values of variables are large and are to be grouped to obtain the frequency for each group, the midpoint of the class interval will now serve as the value x. Let us illustrate this with a worked example. Find the mean to the data in table 4. Solution 1. Create column 3 to show the midpoint x, or the class mark of the class interval. For example, for class interval 20 to 24, the class mark is obtained by adding the lower class interval plus the upper class interval divided by 2. For example, 20 plus 24 divided by 2 equals 44 divided by 2 equals 22. 2. Create column 4 is equal to Fx in bracket column 2 multiplied by column 3, close bracket. 3. Using the formula, x bar equals to EFX divided by EF is equal to 1710 summation of column 4 divided by 40 bracket summation of column 2 is equal to 42.75. 4. To calculate the mean from data with frequency and class interval with assumed mean, in using the assumed mean, we use the formula bar x equals to A plus EFD all over EF, where bar x means mean, A equals an arbitrary mean just assumed, D equals to deviation in bracket x minus A, difference between the assumed mean and the variables. EFD equals to summation of the frequency f multiplied by the deviation d. EF equals to summation of all the frequencies. Example, using an assumed mean of 40, calculate the mean for table 11. Solution 1. With column 1, 2, 3 from table 11, create column 4 is equal to D. 2. Create column 5 equals to FD. 3. Calculate using x bar is equal to A plus EFD all over EF. X bar is equal to 40 plus 110 divided by 40. X bar is equal to 40 plus 2.75. X bar is equal to 42.75. 5. To calculate the mean from data with frequency and class interval with coding method. In using the coding method, use the formula mean is equal to A plus EFUC all over EF, where x bar is equal to mean, A is assumed mean, C is class interval, U is D/C deviation x minus A bracket divided by class size. Example, using table 12, calculate the mean using the coding method. Solution. 1. Using column 1, 2, 3, 4 from table 12, create column 5 equals U. 2. Create column 6 equals FU. 6. To calculate the grand mean, sometimes the situation may arise where we know the mean of several groups of scores and we want to calculate the mean of all the scores combined. We calculate using the formula x bar overall equals to n1 x bar 1 plus n2 x bar 2 plus nk x bar k divided by n1 plus n2 plus nk, where n1, n2, nk is equal to number of scores in the first, second, last group. X bar 1, x bar 2, x bar k equals to mean of groups 1, 2, last group respectively. Example, the mean of marks scored by 12 students of MSW1 in statistics is 55, while the mean of 15 MSW2 students is 70. 10 PGDSW students scored 65 as a mean in Statistics 2. Find the mean scored mark for all students in the Department of Social Work. Solution. Using the formula x bar overall is equal to n1 x1 plus n2 x bar 2 plus n3 x bar 3 divided by n1 plus n2 plus n3, where x bar 1 is equal to 55, n1 is equal to 12, x bar 2 is equal to 70, n2 is equal to 15, x bar 3 is equal to 65, n3 equals 10. X bar overall equals 12 bracket 55 plus 15 bracket 70 plus 10 bracket 65 divided by 12 plus 15 plus 10 equals 660 plus 1050 plus 650 divided by 37 equals 2360 divided by 37. X bar overall, that is mean overall, equals to 63.784. Summary. In this lecture, we have discussed one of the three major measures of central tendency, the mean. Arithmetic mean is the total of the values of a variable divided by the number of values. For the ungrouped data, it is mean is equal to EX over N, while for grouped data, it is mean is equal to EFX all over EF. We also calculated mean for data with frequencies and class interval with assumed means and with coding method. We have come to the end of study session 7. Thanks for listening.